This is going to be an explanation of how to do problems involving angles of elevation and angles of depression. The 6 questions that I'm going to solve are located in your booklet at the back of week 2 on trig, or week number 11. And I'm going to read the question to you and I'm going to solve it in front of you. And I'd like you to follow along. The first question says, what is the length of a shadow cast by a person who's 187 centimeters tall when the sun is at an angle of elevation of 61 degrees? So what you have to understand about angles of elevation questions is they're always going to involve an angle made between the horizontal, which is sometimes the ground, or it could be a line you have to draw, but it's always an angle made between the horizontal and where you're looking up to. In this case, we're looking up to the top of a person. So we're doing an angle. We're going to use the angle of elevation concept to solve a problem, asking us to find the height, the length of the shadow actually, which is along the bottom of a triangle in yellow. So what is the length of a shadow cast by a person 187 centimeters tall? That's the height of the person when the sun is at an angle of elevation of 61 degrees. So the angle of elevation again is always put on the bottom corner of your triangle between the horizontal, which is the yellow line, and the line of sight from where you're looking up to the top of the object. So 61 degrees is going to go here. With respect to 61, the 187 is the opposite side, and the distance we're required to find, x, is the adjacent side. The length of the shadow. The shadows are always on the ground. Therefore, we are required to use the tan function, because the tan is the ratio used when you have the opposite and the adjacent. You must always pick the appropriate ratio. We don't have the hypotenuse in this triangle, and we're not asked to find the hypotenuse. Therefore, that eliminates us using either the sine or the cosine, because both of those ratios require a hypotenuse. We do know the tan of 61 degrees. We can get that from a trig table or from the calculator. That's a constant value, which we can look up. And we have the opposite of 187. Try to find the adjacent, which is x. If you set up your equation, tan of 61 over 1 equals 187 over x. To solve this question, you're going to cross multiply. Like all proportions, x is going to equal 187 times 1, which is 187. You're going to divide that by the value for the tan of 61 degrees. When you do that on your calculator, you're going to get an answer that's going to come out to 103.655. You reread your question. If it doesn't tell you how to round, then you can do whatever you like. 187 was our, we're going to round this nearest tenths. For practice, 103.7 centimeters would be the length of the shadow. Question 2 in your practice says, what is the angle of elevation of the sun at a time when a pole 18 meters high casts a shadow 16 meters long? There's your pole, vertical, 18 meters high. The pole casts a shadow. Shadows go on the ground. You assume the pole is vertical. And it says the shadow is 16 meters long. What is the angle of elevation of the sun? The angle of elevation is always the bottom of your triangle made looking up to the top of your object and between the horizontal. So the angle in there is the angle we're trying to find. We don't know the angle, but we want to find the angle. With respect to that angle, the 18 is the opposite side, and the 16 is the adjacent side. Therefore, you are required to use the tan ratio again, because the tan of the unknown angle is going to equal the opposite of 18 divided by the adjacent of 16. Put that over a 1. So you multiply 18 by 1 and divide it by 16. As a ratio, you're going to get a value of 1.125. That's clearly not an angle, but if you grab your calculator and you do the second function tan to solve for the angle that would make the opposite over the adjacent equal to 1.125 or 18 over 16, you're going to get an answer, an angle of 48.366 degrees, which when you round to the nearest tenths, an angle of 48.4 degrees, found by taking the opposite over the adjacent. Number 3, a pilot in a helicopter. So you're up in the sky, and it says a pilot in a helicopter just hovering 930 meters above the ground observes a car at an angle of depression of 53 degrees. So when you're looking, this is a new question, looking down. The pilot's looking down at the object. There's your car. Now the angle of depression is very specific. The angle of depression is always the angle made when you're looking down at your object, and that object is going to end up, that line that you're looking down along is going to basically be the hypotenuse of your triangle, and that line is between the object and the horizontal. That angle right there, between the green line and the purple line in this diagram, is called the angle of depression. That angle of depression was given as 53 degrees. In this question, we are asked, how far is the car from a point directly below the helicopter along the ground? We want this length. In order to solve for that length, we have to take that 53 degrees and bring it inside the triangle, applying the alternate angle rule, the Z pattern, because the ground and the horizontal line that you drew up top are parallel. So the Z rule will bring the 53 degrees in. And then you can use basic trigonometry to solve for the question, which is how far from the car along the ground is it from the helicopter. We were told in the question the helicopter was 930 meters in the ground, above the ground. Looking at what we're given with respect to our angle, the 930, that's the opposite side, and the distance along the ground is the adjacent. So yet again, we're going to be solving for our unknown using the tan ratio. The tan of our known angle, 53 degrees, is going to equal the opposite 930 divided by the adjacent, which is x. So to solve for the x, this time your unknown's on the bottom of your ratio. So 930 times 1, which is 930. You're going to divide that by the tan of 53, which is just simply a ratio that your calculator will give you. So when you plug that in, you're going to get a value of a decimal 700.805 and so on to the nearest whole number. Let's say that would be 701 meters, the distance from the car to below the helicopter, using the tangent ratio. Now please note that the angle of depression is the angle made between the horizontal when you're up high looking down and the line of sight. In order for you to get the question 100% correct, you have to show that angle at the top, and you have to bring it inside using parallel line theorem. Question 4. Two buildings are 40 meters apart. From a window 17 meters above the ground in one building, the angle of elevation at the top of the second building is 27 degrees. How tall is the second building? So I have a very primitive diagram here. Two buildings, they're 40 meters apart. We're told that from a window 17 meters above the ground in one building, so we're 17 meters up. The angle of elevation of the top of the second building, so from our window up, elevation is always the angle made between the line of sight when you look up and the horizontal, which could either be the ground or in this case the imaginary line that's parallel to the ground. Looking up from the window, and we are told the angle of elevation is 27 degrees. And we are required to find the height of the second building. Well, we also know how far apart the buildings are, 40 meters. We know we have a right angled triangle. So if you look at all the things that you could do, we could certainly find that height because we have 40 meters in a right angled triangle. We can solve for that side x if we call that the opposite. The 40 is the adjacent. So we're back to using the very commonly seen angle trig ratio of tan. The tan of 27 degrees is going to equal the opposite, which is the upper half of the building, over the adjacent, which is 40. And when you solve that ratio, you're going to end up taking 40 and multiplying that by the tan of 27 degrees, which is simply a constant you can get from your calculator or a trig table, and you're going to divide it by 1, which won't change anything. So 40 times the tan of 27 is going to work out to give you 20.3810. That's the height of the turquoise line in the diagram. We want the height of the building, however, so we're not done. We have to add to that the height from the window down or from the bottom building up, which is the same side in each half diagram. So you would basically add that on, and your total height of the building would be 37.4 if you rounded the nearest tenths, and the unit is meters. Okay, question number 5. From the top of a 78-meter cliff, the angle of depression of the far side of a river, so the blue line is the river, the angle of depression of the far side of the river. So you're looking over at the bank on the far side of the river here. The angle of depression is 41 degrees. So depression are angles. You're depressed, you're down, you're looking down, so it's the angle made between the horizontal and the line of sight, which is your hypotenuse line. That angle is 41 degrees. That's not very helpful outside the triangle, so we apply our Z rule and we bring it inside as well. Now it goes on to say the angle of depression directly across the near side of the river. So we're looking down, the angle of depression directly across the near side of the river. So we're looking down at the river, but now we're looking at the side closest to the cliff. So you would expect that if you're looking down closer, you're looking down harder, and therefore you're looking down at a bigger angle, which is the case. It says 70 degrees. So now we're talking about the angle from there all the way down to the other hypotenuse, and that whole angle, which I'll color the whole angle in to make it more visible. We're talking the whole angle from here to here, to the whole thing, which is going to also equal this whole thing, because of the Z rule, is 70 degrees. So you can show it this way, the big angle, and you can bring it inside. The question asks, how wide's the river? So how far is it from here to here? Well, we have to first of all recognize that we do not have a right-angled triangle that contains x and 41 and 78. That's not a right-angled triangle. But we can make a right-angled triangle of the 70, the 78 height of the cliff, and we'll call the other side y. We can make a right-angled triangle of the 41 degree from the opposite side of the bank all the way back to the edge of the cliff. Let's call that Z. So if I trace these triangles in different colors to help visualize, we could do the whole triangle, which would be 41 degrees, and the height of the cliff 78, and the adjacent side, which would be the whole thing of Z. We can combine that with the smaller triangle, the 70-degree triangle, and then we could find the value of y, then subtract that to get the value for x. With respect to the angles of depression that have moved down to the bottom of the triangle, 70 degrees and the 78 is the opposite, and the y is the adjacent. So for example, the tan of 70 degrees is equal to the opposite of 78 over the adjacent, which is y. Now because the y is on the bottom of the fraction, you're going to have to cross multiply and divide. So whatever 78 divided by the tan of 70 is, will be our value for y. So 78 divided by the tan of 70 works out to be 28, use your calculator, 0.38967. You should never round in a beginning calculation, only at the very last step. Now to solve for z, which is the distance from the far side of the bank way back to the edge of the cliff, you're still using the tangent ratio, but we're using 41 degrees, and we're going to use the opposite of 78 divided by the unknown adjacent side, which we're going to call z. So to solve for z, take your 78 and divide it by the tan of 41 degrees, and that will give you the whole adjacent side. So z is going to equal 89.728735 if you keep going. And don't forget that z is really x plus y. So to solve for x, you're going to take the whole distance, 89.7287, and you're going to subtract from that the 28.3896, and the difference will be 61.339, and so on. So round to the nearest proper, say we do the nearest tenths, the answer would be 61.3 meters, and that's the width of the river, or in other words, in our diagram, the value of x. This last question will be considered what I call a bonus question, and for somebody who really likes a bit of a challenge and is not afraid of algebra, this question is for you. The top of a tree is measured at an angle of elevation of 39 degrees from a point on the ground. So you're out on the ground and you're going to measure the angle of elevation at the top of a tree to be 39 degrees. Now, if you move 12.5 meters closer towards the tree and you measure the angle of elevation from that point, the angle is going to be steeper. In this case, 61 degrees. So 39 degrees and 61 degrees. And the distance between the first point and the second point was 12.5 meters. The question is, find the height of the tree. Well, this is a tricky question because in order to find the height of the tree, let's call it h, we need to know both an angle and a side in our triangle. And we don't. We don't know, for example, in our triangle that has a 61, we don't know the height and we don't know the adjacent. Let's call that x. We do know the distance from the 61 mark, 31 mark is 12.5. Because the height is the opposite and the x is the adjacent, if we could use the triangle to solve that, we could use a tan ratio. The tan of 61 would equal h over x. And the same thing with the 39-degree triangle. If we did know the values, we could do the tan of 39, and we could use the opposite side of h and the adjacent side of x plus 12.5. The problem with this setup is that we have two different letters, and you can only solve a linear equation with one letter. We're going to use some fancy algebra skills to solve this. What you should see in both of these is a common side, which is the height of the tree, which is h. So if we were to rearrange the top formula for h would equal, in the top triangle, from a top triangle, x times the tan of 61, and in the bottom triangle, h would equal x plus 12.5 times the tan of 39. Well, as we know, the height of the triangle is the height of the tree is the same in both diagrams. The tree is the tree. So we can then take our equation and rearrange it, because we know that h is equal to x times the tan of 61, but h is also equal to x plus 12.5 times the tan of 39. Therefore, if we set them up to equal each other, we can make a new equation that says x times the tan of 61 should equal the same thing as x plus 12.5 times the tan of 39. H is equal to h, so what's equal to h should equal what's equal to h. This is where the algebra comes in. The tan of 61 is going to equal use your calculator, 1.804. Use a couple more digits to keep the rounding, 0.0477 times x. And on the right-hand side of our equation, we're going to do x times the tan of 39, and we're going to do 12.5 times the tan of 39. The tan of 39, of course, is a constant. And that constant is equal to 0.8097840. If you take that value and multiply that by x, you're going to get it itself. 0.8097840x plus 0.8097840 times 12.5 is going to give you a new number, which will equal 10.1 10.1.223. 10.1.223. Now when you add these together, or group them together, flashbacks to algebra, you want to put x's on both sides. Bring the x on the right over to the left, and you're going to get 1.804077x minus 0.809. Put those two terms together, you bring that over and change the sign, you're going to end up with the difference of 0.9942637 y. It's going to equal 10.1223, and you want to solve for y. So you divide by the coefficient, 0.99426 on both sides. So y is going to equal, where the hell did y come from? That should be an x. Same, it's an unknown variable, but it should have kept it consistent with the x. The x is going to equal 10.180699. Now x is not the answer. We're looking for the height of the tree. So you have to go back and substitute in your one of your two original equations that has the x. So say we went back to do the tan of 61 degrees equals h over x. X is now 10.180699. You can solve for h by doing your 10.1806 by the tan of 61, and it's going to give you 18.3664, which is 18.4 meters. So that question is a little more difficult because it requires you to make an equation that's simultaneous and use two trig ratios at the same time, and algebra skills and trigonometric value skills. Good bonus question, but not necessarily a question I will ever ask you on a regular test. Hope this helps with angles of elevation and depression. Thank you.